Hi. I've selected several problems from the homeworks for Unit 3 as a means to help you decide to practice for the test. These questions look a lot like the questions in the test. And I'm going to walk you through these with the idea that you're going to try them on your own and you just need some help in looking at the answer. And so I'm going to show you, if we're going from polygon Q is where we're going to. We're going from P to Q. And just to point out, when you do a dilation, if you have the point of dilation is right here, you take your original figure, and maybe it looks like this, and you're going to scale it. If I'm going to get smaller, it's going to go this direction. So if my scale factor is 0, that's the point of dilation. There is no value there. If it's equal to 1, my scale factor, it's still scaled, but it's by a factor of 1. This is where it's congruent. If it's going to get smaller, my scale factor has to be between 0 and 1. And if it's going to be greater than 1, then it would get larger. So I'd get a bigger one way over here, something like this. Also know that if I'm going from the starting value of a length and I multiply it by a scale factor, this will get me to my scale factor I'm going to. We're looking for the scale factor, and we know where we're starting from, which was 4 times the k value is equal to 3. So if I divide both sides by 4, I get k is equal to 3 over 4. Now, we didn't need to know this right now. What we needed to know was, what is the value of y? So if I'm going from 6, what is it equal to at y? 6 times my scale factor of 3 over 4 would get me to y, and this is going to be 18 over 4, which is the same as 9 over 2. Here we have triangle ABC is taken to triangle A prime, B prime, C prime. So if this is ABC, and we're going to A prime, B prime, C prime, which is larger than the original, A prime, B prime, C prime. And I go back to the drawing I did on the previous page. You'll notice to be larger, it has to be greater than 1. My scale factor has to be greater than 1. Which of these numbers is greater than 1? Equal to 1 gets me congruence. It doesn't get me a scale factor larger. This is going to be larger than 1. What is the scale factor? Again, when you're going from something, you multiply it by a scale factor to get to where you're going to. We're going from the blue to the green, so we have 4 times our scale factor, which we don't know yet, is equal to 3. Divide both sides by 4, our scale factor is 3 over 4, or 0.75. 3 over 4 works. Getting smaller from blue to green. This is important when you do a scaling of a figure. You can take the point of dilation, you can draw a line through any of these points. I could go this way, I could go this direction here, through any of the points that are on here. And you're going to multiply the original value by the scale factor, and it's going to start at this point. So if I'm scaling going from this larger figure to the smaller one, if I were asked you to draw this figure, if I didn't give you this, if I gave you the scale factor and you were to draw it, first of all, we're starting at 6. I'm going to do the same thing we did before here. My length, where I'm starting from, I multiply it by a scale factor to get to the length where I'm going to. The length I'm starting from is the blue. This is 6 times the scale factor is equal to 3. Divide both sides by 6. K is equal to 1/2. So you can see that my scale factor is going to be 1/2. But just know that if I were going to draw this, I start at the original. Instead of going this full length, I would go half of this length. Instead of going this full length, I go half of this length. Because I'm going to ask you to draw a figure given a scale factor. You start at the point of dilation. Draw your line through each of the vertices to do that. Polygon has a perimeter of 18 inches. Notice the perimeter is going to be whatever it is, the length plus the length plus the length, length plus length plus length plus length. And so just as you have the formula of our length that we started from times the scale factor is equal to the length of the new one, we're going to use the perimeter. You could also work with this. And I didn't explain this, but wanted you to try it out. So we're given the original is 18, and our scale factor is going to be 3/2. So when we do this, it's going to be getting larger. If I take half of 18, that's 9. 9 times 3 is 27. 27 is my answer. Quadrilaterals P and Q are similar. That means that their angles are congruent. It means their sides are proportional. I do not have let's see, I got 4 and 5. I've got 3 and something here. And I've got 2 and 2.5. Well, if I do 2 to 2.5, well, it depends on if I'm going from P to Q, or from Q to P. And remember, our formula is where we're going from times the scale factor is equal to where we're going to. So if we're starting at 4 and we're going to 5, this would be 5 is equal to the scale factor times 4. So our scale factor is equal to 4/5. Does that make sense? Are we getting, wait a minute, 5/4? I did that wrong. 5/4. That would make sense because I'm getting larger. It's going to be more than 1 going from P to Q. Now, if I'm going from Q to P, my starting value is 5 multiplied by a scale factor to get to Q, which is 4. My scale factor here would be 4/5 going from Q to P. Definition of similarity. It's true that they have to have the angles have to be congruent, but this is not the definition. And it's true that the sides must be proportional. This is not the definition. What's wrong with this one? If there's a sequence of rigid transformations, taking one figure to another, then they are similar. No, that would be a definition of congruence. For similarity, it has to be rigid transformations and dilations. Dilation is when it's getting larger and smaller. To solve this problem, we're going to separate the triangles. And if we do that, we have the one triangle here. The other triangle looks something like it. I'm not doing a very good job of this. The big one is ABC. And we have A prime, B prime, C prime. The angles are congruent. They both have a 40-degree angle here. And they have this angle is in common to both of the triangles. So you know that they're similar by the angle. Well, you don't know that, but you know that this angle is congruent to itself on both of these. Are the sides proportional? Well, this long leg side is 9, and this one is 6. And on the short one, this is 6, and this is 4. So is 6 is to 9, is that the same as 4 is to 6? Yes, that's 2/3. So the sides are proportional, and the angles are congruent. So by side angle side, triangle congruence, triangle similarity theorem, the two triangles are similar. Now, what we're asked to find is what is the length of AB, given that A prime, B prime, given that AB is 12. Well, this is 12. And remember, our scale factor, if we're going, what we're going from times the scale factor is what we're going to, just to make sure that we get this correct, it should be 2/3, not 3/2. Let's just check that out. If I'm going from 6 to 4, 6 times K is equal to 4. My scale factor is going to be 4/6, which is 2/3. So if I want to know what this value, the large one, would become over here, I would multiply the scale factor, where I'm starting from, times my scale factor, 2/3, and I get 24/3, which is 8. You could have set up a proportion. You could have called this x and say x is to 12 as 4 is to 6. And maybe at this point you notice this is double here, so this would be double. And if you don't, you can always cross multiply. 6x is equal to 48. 48 divided by 6 is 8. And I think I'll stop right there for this set of practices, for this video.